So in this video, we're going to look at some examples from the last lecture. Sorry for the abrupt cut there. What happened was on this laptop, I always forget, as I mentioned, I'm getting a new one this weekend in order to be able to simultaneously run all of my technology. But long story short, the webcam and the actual dock cam won't work at the same time. So I have to unplug the webcam and plug in the dock cam here. So what we're going to look at are two examples from the actual PowerPoint. We're given information about two vectors. I wouldn't say it's in polar form, but it's kind of like a description that sounds like polar form. So we're told that the magnitude of A is 1. That's certainly one of the two parameters of polar form. However, we're not actually given an angle for A. We're just told that it's oriented horizontal. And magnitude of B is specified as 2, and we're told that it's vertical. And we want to sketch A and B. And then let's actually kind of quantify what the direction of those are using the counterclockwise convention from the positive x-axis that we introduced in the last video. So remember that the way you want to do this is to take and draw an xy plane and just position your two vectors at the origin. So here is my x-axis, here's my y-axis. So in order to draw the vector A, I'm going to draw an arrow that has a length of 1. And I want, remember, vectors have two kind of ends to them. They have a tail, that's where it starts, and they have a tip, that's where it ends. So I want to draw an arrow that's 1 unit long and is aligned in the horizontal direction. So we're just going to interpret horizontal as meaning that it goes purely along the x-axis. So imagine that on my coordinate system, this is 1 unit long. What I'm going to do in order to draw A is put the actual tail of A at the origin, draw the line out, and I'll do this in blue just to make it a little more visible. Draw the line out, and then put the actual tip ending right at 1. And you can write the angle, the vector rather, A over top if you want kind of a label on your graph. Now the question might be, well, what is the actual angle of A? Just based upon looking at the diagram that we've drawn. So remember, the angle is defined as the angular displacement from the positive x-axis. So the question is, in order to draw that vector, did I have to rotate it all? No, definitely not. So there is no angular displacement. So the angle of A measured using that convention that we spoke of earlier is actually just going to be 0 degrees. Now for vector B, we're told that it has a magnitude of 2 and that it's actually aligned in the vertical direction. Now it didn't matter that this is 1 unit as long as I only had A drawn, but the second that I called that distance 1, I need to be as consistent as I can and make the length of B be double that. So I'll call that 1, I'll call that 2. And what I'm going to do, the reason that I went up along the y-axis is we're told that B is vertical. So I need to draw an arrow that starts with a tail at the origin and then goes up to 2 units along the vertical direction. So that's actually B. So it's hard to see because these are actually on, if you just want to see what they look like without a coordinate system there. There is A and there is B, and that is 2 long and this is 1 long. So the question is, what is the angle of B? Well, how did I get to B? I go from the positive x-axis and I rotate in the counterclockwise direction, that's positive, by 90 degrees. So what that means is by the convention that we're using, the angle of B is just going to be 90 degrees. So we've been able to take kind of those qualitative descriptions of orientation, horizontal and vertical, and translate them to actually numerical descriptions of the angle. So the second thing we want to do is sketch and compute the magnitude of 2a. Well, if you have a new vector 2a, remember that all that it's going to do when you multiply a scalar, in this case 2, by a vector, the new magnitude, so the magnitude of that new vector is just going to be 2 times the magnitude of the old vector. And the magnitude of the old vector we were given to be 1, so that will just be 2 times 1, so that'll just be 2. So if you think about it, all that that's going to do is take the original vector A, it's not going to change the actual direction, it's just going to make it double the length. So if that original vector is A, the vector that I drew over top of it that's twice as long would be 2a. So 2a there, and that's just A. A second example here, negative B, magnitude of negative B. Well, the key point that, and this is kind of a tricky one, is how do you deal with actually having a value of negative 1? So note, if you set it up the same way that I did above, if you try to show this in a pretty notation way, you'd say that really it's negative 1 times mag B. But remember that the magnitude of an actual vector is always positive. So a better way to show this, and if you kind of want a notation to use that works for whether the scaling factor is positive or negative, you can actually take, and when you pull this constant out, whether it's positive or negative, just put an absolute value sign around it. So what that will do in this case is if you take the absolute value of negative 1, that's just going to be 1. Well, that's just going to be the magnitude of B. So what that is saying is when you multiply by a negative 1, the magnitude doesn't change at all. just like if you were to multiply by a positive 1. But when we actually look at, if you think back to that description that I gave you in the prior prior video in the PowerPoint, if you had the vector b going up by 2, even though that multiplying by -1 doesn't change the actual magnitude, it will change the direction. It's going to rotate the direction by 180 degrees. So if you think about it, if I draw in a little coordinate plane, and this original angle was 90, if I rotate that by 180 degrees due to the -1 term, it's going to take that vector that was pointing up and it's going to make it point purely down. And finally, for part C here, if I have the magnitude of 1/2 b, remember, use that same approach I did before, make it the magnitude of 1/2 times the magnitude of b. Of course, since 1/2 is positive, that's just going to be take the magnitude of b and cut it in half. And since the magnitude of b, if you remember, we were given was 2 at the top, 1/2 times 2 is 1. So the main point of me showing you this is you can have an actual scaling operation that makes the magnitude smaller. So originally, the vector b was in the vertical direction and it was 2 units long. So if I were to scale that by 1/2, and I'll kind of just draw it to the side that we can see it, it's just going to not change the direction because the quantity is positive, but it will cut the magnitude down in half. So hopefully that made sense to everyone. I will scan this and include it in the actual module for this week under the lecture as well, in case you can't read any of my writing or just would rather have the actual scan of my work. And I will see you all in the next video.